dudes, I'm back again, and I'm ready to get into the actual rendering and reconciliation algorithm. So I did a few things on the code, which is I cleaned up things. So if you remember, we used to have all the DOM update and create DOM element functions here. Now I moved them to a separate library called DOM, where we have create DOM element, we have update DOM element, and we have the index files, so you can have them anywhere in the project. And I also created a separate separate folder which called reconciliation, which has an index, yep, that's pretty much it. And now what I did is imported render. I know that render is now put to React DOM, but as I said, like a few videos earlier, I want to treat them in the same like sort of folder / package. So what I did is just mimic the API of React. So I have render with the first argument of an element and the second as a DOM node. And I have render here, which will point to the reconciliation. So let's just put it there. And what it will do is console log the element and DOM node out. Yep, alright. So now let's start from here. So what we want to do is it's gonna be an interesting thing. So I'm just gonna sketch out a few things. So we will need the request idle callback function, which we're gonna get from window request idle callback. So I'm not sure if it's cross-browser compatible. To be honest, I only did this on Chrome, so there might be some polyfill needed if we use other browsers. I'm not sure, we can try it out, but first let's just stick to Chrome because I know that it works on Chrome. So we need request idle callback, and the way what we're gonna do is the whole point of Fiber is to be able to stop the algorithm at any point of time, and the way to do that is have a long-running task and like slice them into fibers. And the way to do it is okay, actually let's try to mimic something. So what I want to do is just imagine, so there are initial renders and there are things that can trigger a re-render. So things that can trigger a re-render is basically, if you don't count the hooks, are set state or force update. But like force update is highly discouraged even by the React team. So we're just gonna consider the initial render and set state. So, and we're just gonna focus on the initial render for a long time. So if you have the initial render, what you want to do is you want to put this as a long-running task and then somehow divide it to smaller pieces. So what we can do is we can have a const task queue, and you can say task queue push like element and node, right? So this way, every time you render, you know that this kind of task is in the queue and it's waiting to be processed. Good. Okay. So what we can do and what we should do is okay, so once it is there, we should invoke invoke a function to perform work, but in such a manner that it only starts working on the pieces when it knows that it has some time. So let's just create a constant with enough time, call it 1, so it's going to be 1 millisecond. So we can do request idle callback and perform task, which is a function. So we can call current perform task, and it will have the argument like a deadline, and okay. So we have task queue, and I said that this task queue will have subtasks. So okay. So we can start working on the long task by creating a work loop with the deadline. Remember, deadline has a time remaining, and that time remaining is updated at every invocation, so it's not a static value. So we can have the work loop, which also has the deadline, and now comes the interesting part. So we have task queue where we have tasks and we have subtasks. So if I call render like 3 times, then there's going to be 3 items in the array, task queue array, and I need to process them, but the way to process it is get one out of the queue, get the first subtask of that long running task, process it if I got enough time, give back the control to the browser, and if I get another time, process the next subtask until I'm finished with that one, and then go to the queue and grab the next one. So that's how we're gonna proceed. So what does that mean? This means that we need to check if we have a subtask at hand, and if we don't have any, then we need to get first subtask, which will grab the first subtask somehow. Just don't care about it now. And it will get us back the first subtask. But if we have a subtask, then comes the interesting part, which is the core of the whole engine, basically, which is a while loop. And it's gonna be quite similar to what we had here. So it's gonna be somewhat similar, I would say. So okay, so right, there's a subtask and we still have time, in other words. Then execute subtask, and that function gonna do basically all the diffing stuff. So const execute subtask subtask. And the tricky part is we don't care about the implementation at the moment, but it will return it, not even here, it's just, let's write a comment. So it will return the next subtask. Or I should say, yeah, let's call it subtask first. And it will process it, and it also will return the next subtask. So we can assign the global one, and you know how, so you can see how this while loop is gonna work. So if the subtask is not undefined and we have time executed, but the execution will return and reassign the next one, and the iteration starts over, but there will come a point where everything is proceeded, and now comes the everything is proceeded, yeah. So there will be other stuff here. I just don't want to complicate things over. So if it's done, then so this work loop was called from this line. So let's assume that every subtask is done. Now we get out of the loop, and let's see what we can do. So okay, so there are two ways why we get out of the loop, right? So one is that you ran out of subtasks, and the other one is that there were not enough time. So if there were not enough time, it makes sense to just simply check again if there is a subtask, or if there is not, because most likely everything was done, then just check that are there anything in the queue. So or task queue dot length is not equals or just simply greater than 0. If so, start the thing all over again, right? Yeah, I guess so. Oh, not for loop, sorry. Because that will do nothing. I need to have request idle callback again. So request idle callback and perform task again. So yeah, that's gonna call itself, and yeah, I guess. Okay, so yeah, it's a bit complicated, but let's just go over everything. So we push a new task. It can be anything. I even just get it out and just put it like some magical task, right? So we don't know what it is at the moment, but it definitely has to do with element and DOM, otherwise we wouldn't provide these as arguments here. So I'm gonna, so not me, but the algorithm is gonna push this as a task onto the global task queue variable, and gonna request idle callback. In other words, tell the browser that if you're not busy, start working on this thing. So what happens next is we call perform task. It has the thing to the deadline, and it calls work loop, goes to work loop and checks. Okay, so if there is a subtask, if there is no subtask, then grab the first one. And grab the first one means that basically what it will do is let task equals task queue shift. So that's what it will do. So it pops basically the first item from the queue, and it will do some magic here, like I'm gonna call it magic, and from that task it will derive the first subtask. We will get back to it later, but that's more than enough for our understanding at this point. So get first subtask is gonna get the first subtask from the given big work. Then proceed here. So it means that now if we have, so it might return null. So if it's null because everything is empty basically, so obviously it can return null because it might be empty, then it can be null. Or simply the browser is busy, then go ahead and finish the loop. Then we come here, and if that was really the case, that there was no subtask, then we are good. But then go ahead and check if we have any main task in the queue. If we don't, then just finish everything and the algorithm ended for now. But if you, okay, let's get actually back here. So if we have a subtask and there is enough time, so the browser is not busy at the moment, then just start doing the work, and start doing the work will work in such a way that it will calculate all the necessary things and will return the next subtask. So it will be assigned to the global variable, and it will start a new iteration. So if you still have enough time to start working until you run out of time, or so you can either run out of time, but if you did all the necessary calculations, at some point the subtask is gonna be undefined or null. So you get out of the loop again. So there will be two cases. If you run out of the loop because you did not have enough time, then here, when you get here, subtask will be not undefined. So what we do is just simply request idle callback. In other words, resume processing whatever you were doing when you have enough time, right? But if the subtask is undefined or null, that means that everything was done. So let's see if we have another big thing to do in the queue. If so, start everything all over again. So we're going to call request idle fallback with perform task. We will see that the subtask is empty because it was empty here. We're gonna shift the queue and everything starts all over again. But if it's empty, then just skip it and we are done. I hope that kinda made sense. So yeah, I think that's for it for this video. I hope it made sense how this little loop and request idle callback works. And yeah, I'm gonna continue with the algorithm from here in the next video. See you then, guys.